Consider a binary number 1010.011. In general, a number with a decimal point is represented by a series of coefficients as follows. Starting from here, let a sub 0, a sub 1, a sub 2, a sub 3 point must be here, and here a sub minus 1, a sub minus 2, and so on. Let me name this expression as A. So by comparing 1010.011 to these expressions, I come across that A sub naught is equal to 0, A sub 1 is equal to 1, A sub 2 is equal to 0, A sub 3 is equal to 1. Similarly, on right side of this point, we have A sub minus 1 is equal to 0, A sub minus 2 is equal to 1, A sub minus 3 is equal to 1. Starting from here, so 0 into 2 raised to power 0, that's for this one, and this element will be, as it has a coefficient of 1, into 2 raised to power 1. This is 0. For this one, its coefficient is 0, 2 raised to power 2, plus for this its coefficient is 1, and for this base its power will be 3. Now we are done with this one, and for this part, plus its coefficient is 0 and 2 raised to power minus 1. Now for this one, plus its coefficient is 1 and 2 will have a power of minus 2, plus for this its coefficient is 1 and its power will be minus 3. When these have been given, we have to remember one thing, that whatever the base may be, it will be the power of 2 as well. If we have 0 over here, we will have the power of 0 of this 2. If we have 1, we will have the power of 1 of 2. And for this A sub 2, as this is 2, so 2 will be the power of 2 over here. Now for this, its coefficient into power of 2 will be this base, which is 3. Okay, now solving it, we will get as 1 into 8 plus 0 plus 1 into 2, it's simple, 2 plus 0 plus 0 plus 1 into 2 raised to power minus 2, it will get us 1 by 4, and this will get us 1 by 8. Now we do have 8 plus taking out the zeros, 2 plus it will be equal to 0.25. You can use the calculator, plus, and this one will be 0.125, I guess, if I am not wrong, and by adding it will get me 10.375. okay, so I come across a binary can be converted to decimal by forming the sum of the powers of 2's of those coefficients whose values is 1, and this binary numbers has 4 ones. You can see 1, 2, 3, 4, and 1, 2, 3, and 4. So whose coefficient is 0, you can see this one turn out to be 0, so there is no need to write it. So you have to take account of those coefficients whose values is 1. So if you ignore such coefficients and the start, you are good to go. Okay, so here is a step-by-step solutions to convert a ternary base 3 number to a decimal base 10 number. Now let's take an example of ternary number, that is 2101 to base 3. In order to do so, what I do personally, I write the whole number, as there is no decimal number part involved over here. That's why I write it. I do this way. Here I will have to put something, plus 1 into, I always leave some space, plus 0 into plus 1 into something we have to write. So what I have to tell you, that we have to identify the place value of each digit. Starting from the rightmost digit, assign place value as a power of 3. Here we are dealing with ternary, so here it will be 3. And then now starting from the rightmost digit, assign place value as a power of 3, increasing by 1 for each position to the left. As we go from right to left, we have to increase it by 1. What I mean by this one, this will be 3 raised to the power 0, 3 raised to the power 1, 3 raised to the power 2, 3 raised to the power 3. Okay, now we have to simplify it. So 2 and 2, 3 3s are 9, 9 3s are 27, plus 1 and 2, 9. It will turn out to be 0, plus 1 and 2, 1. So we have 2 and 2, 25, 27, make it as 54, plus 9 plus 1. So we have 64. So we can write, let me change the color. This 2101 to base 3 is equal to 64. Okay, and decimal number. Now let's solve quaternary to decimal. Here is a step-by-step solutions to convert a quaternary number to a decimal number. Let's take a quaternary number and the same number, but let's change its base, like 2101 to base 4. Okay, we have to identify the place of each digit or coefficients. Now starting from the rightmost digit or coefficient, assign place value as power of 4, increasing by 1 per each positions to the left. Now places values will be like 4 raised to power 0, and writing the coefficients, these coefficients 2 and 2, 4 plus this coefficient 1 and 2, this base 4 plus this coefficient 0 into this base, whatever the base may be, plus this coefficient into 4. Now as I told that starting from the rightmost coefficient, assign its place value as a power of 4. So we will take start from 0 and then increasing by 1 for each position to the left. So 0 plus 1, so it will get 1, 2 and 3. So 2, 4, 4s are 16, 16, 4s are 64, plus 1 and 2, 16, plus 0, plus 1 and 2, 1. And finally we get 128 plus 16 plus 1. Okay, so the final answer is 140. Thus, the sum obtained is the decimal equivalent of the quaternary number 2101. Okay, so it has a decimal equivalent of 145. Thus, from these examples, we came to know that a number expressed in any base, let's say base r, can be converted to its decimal equivalent by multiplying each coefficient with the corresponding power of r if it has base r in adding. So now let's do the last example, octal to decimal. Now let's take now let we have an octal number or base 8, that is 630.4 to base 8. Now let's write the coefficients, 6 into 8 plus 3 into 8 plus this coefficient 0 into 8 plus this last one 4 into 8. Now remember that this is the integer part and this is the decimal part. So what you need to do from here, from this rightmost digit of this whole number, which is 630, in simple or in decimal we call it, that after on left side of point you have to take start, and from here we have 1 and then increasing by 1. So 0, 1, 2, S4 is on right side of point, this decimal point, so it will be minus 1. Now after calculation, after using calculator, you will get 408.5 to base 10. Now I am giving you 5 questions as a homework. I recommend that you must suggest as answer in the comment section. Thank you. See you in next lecture. Alhamdulillah, 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 alhamdulillah.